Okay, we're going to practice some more simplifying expressions, this time some expressions that have some variables in them. So a variable is just, typically we write it as a letter, but it's a quantity we don't know. So maybe x is 2, in which case I can figure out what this number means. Maybe x is 7, in which case I can figure out what this number means. But just in case I don't yet know what x is, I should probably leave it as the letter x and see how simple can I get this to be. So let's see how far we can get using our operations we've already talked about. So order of operations says we're supposed to look at parentheses first. I don't see any. Then exponents, I do see one of those, 2 squared. So I should probably do that next. So write this as 6x minus 2 squared would be 4x plus 30. Okay. Then we have a couple ways to proceed from here. So I see 6x minus 4x, and that's what I need to deal with next. And there's a couple ways to deal with this. One way to think about it is we have 6 x's. We have 6 of something, and we're taking away 4 of something. Well, if you had 6 somethings and you took away 4 somethings, you have 2 somethings left. So 6x minus 4x would be 2 x's left. Another way to think about that, or another way to write this is actually the distributive rule in disguise. If we had a number multiplied by a sum or a difference, we would have to distribute the x times the 6 and the x times the 4. So our distributive rule was written in terms of multiplication and addition, but really we said subtraction is addition in disguise. So 6 minus 4 is the same as 6 plus 4, and if I had to multiply x times 6 minus 4, we'd multiply x times 6, we'd multiply x times 4, and so we would get exactly the same as the step before. This is actually going to be a recurring trend in mathematics, is a lot of times working backwards is easier than working forwards, so sometimes we'll have to just guess and then double check by working backwards. So if I guess that this is what it's supposed to be, working backwards would be using the distributive rule. Okay, and then now that 6 minus 4 is in parentheses, 6 minus 4 would be 2, and so I confirm my previous guess, or the previous thought process, that 6 of something minus 4 of something would be 2 of that something. So 6x minus 4x would be 2x's. I'm not actually going to mess with this. I'm going to leave this as my final answer, because 2 times unknown number plus 30, I can't say that's 32 because it depends on what the x is. I need to do the multiplication here before I can add anything. So when we try and add numbers, we typically only want to deal with adding like terms. X's with x's, numbers with numbers. If this had been plus 7, then I could add 30 plus 7. 30 and 7 being like terms or like numbers, but an x expression and a constant expression aren't similar enough that I could try and add them. So we'll just leave it like this. Okay, let's try another one. Okay, so my expression is 2 times 3 plus 20y divided by 5 minus 6. Okay, so our rule says we do parentheses first, I don't see any, then exponents, I don't see any, then multiplications and divisions. I do see several of those. So let's underline them and then work on them left to right. So we have a 2 divided by 3. We have 20y, which is an implied multiplication, and then divided by 5. Which is a division, and then that's it. That's all the multiplications and divisions that I see. So let's work on them from left to right. 2 times 3 would be a 6. 20 times y divided by 5. That would be the same as 20 times y divided by 5. And we should be able to cancel a 5 or say that's 25ths times y. The 20 divided by 5 is going to end up spitting out a 4. So we'll have 4y minus 6. And so actually 6 minus 6, those are like terms. I can add those two together. Maybe use my rule of addition that says you're allowed to shuffle the order. That's the this is the commutative law. We switch the 4y and the -6. And then 6 minus 6, we add those first, gives us a 0 plus 4y, which would just be a 4y. Okay, I feel like I need to go back and explain this step a little bit. Try and make that a little more clear. We have a 20 multiplied by a y and then divided by 5. So I give myself some room to think about that. Just like we said, we can change the order of additions and subtractions as long as we keep in mind the subtraction is adding a negative. If I talk about division, division is really multiplying by a fraction, or multiplying by the reciprocal, this fraction where the number is in the denominator. So if I think about this expression in terms of multiplication, dividing something by 5 is the same as cutting it in 1/5. Right? Dividing a pizza in 5 is the same as taking 1/5 of the pizza. So if I think about it this way, then now everything is being multiplied. I can shuffle the order and say this is 20 times 1/5 times y, and 20 times 1/5, 20 divided by 5 would be 4. So that's maybe a better argument for why this thing turns into a 4y. Okay, this middle expression, the 6's end up canceling for a different reason.